Welcome. In this video, we're going to explore this sequence here. We're going to find an explicit formula for it and then decide what happens to this as n grows very large. So let's begin by identifying some traits here. Well, I see we begin with a negative value, and then here we go to a positive value, and then a negative value, and a positive value. So when you see anything like this, So when you see this oscillation between positive and negative, what you need, well, you need a factor of -1 to the n or -1 to the n plus 1. So what this does, it'll multiply -1 by itself, and if you do it an even number of times, you get a positive. If you do it an odd number of times, you get a negative. So that's a great start. So what's some other trait we notice? And I'm going to label this. This is the first trait we noticed here. The second trait I notice is the numerator. That is, the numerator is always 1. Okay, so based on these clues, based on 1 and 2, I am going to say my sequence definitely just has something like this as its numerator. So when I write this out, I'm going to definitely have this in my numerator, and I haven't decided what's in the denominator yet, but just to give you a preview of where my mind is going. Okay, so let's talk about our denominator. So let's think of our third thing we're going to look at here. So the third thing we're going to look at is the denominator. Well, this first term definitely does have a denominator, and I'll show you here. That's like 1 over 1, right? So these denominators are increasing. I start with 1, go to 2, go to 3, go to 4. So they're increasing. They're incrementing by just 1. So this tells me the first term is -1 to the 1 power divided by 1. And I'm going to go ahead and replace these with my n's to make my series. So that means my series here can be expressed. So -1, +1/2, -1/3, +1/4, and so on can be expressed as just -1 to the nth power divided by n. And we're beginning at the first term to infinity. Now, since I'm out of space, I'm going to rearrange again. Well, maybe not again in this video, but I tend to rearrange a lot. So let's go ahead and rearrange. Okay. As n approaches infinity, what happens to our sequence? Well, let's see the limit as n approaches infinity of -1 to the nth over n. Well, let's consider odd terms and even terms. So the odd values, so for odd n, what we have is the limit as n approaches infinity of negative 1 to the n, and that's just 0. For even n, what we have is the limit as n approaches infinity of 1 over n, and that also is 0. So the sequence will converge to 0. And if you wanted to graph it, say this is 1, 2, 3, 4, and here we have, say, 1 and negative 1. Well, our first term would be here, our second term would be here, our third term would be here, our fourth term would be here. And so as you keep going, you'll notice it'll just get closer and closer to the x-axis. I hope you found this helpful.